Welcome back to another video of Jai Balaya series. My nose is blocked, but I have to do this topic. See, today we'll be talking about the storage classes in C, and this is a very important topic, not just for your PPS. This question will be asked in every single technical interview you are going to attend in the future. Okay, this is a very high level topic, and everyone needs to know it. So, what is a storage class? Talking in very simple words, whenever you initialize a variable, say int a, or you initialize a function, say int add, whatever you want to do. Okay, a storage class decides what is the visibility or the scope of that variable. Like scope, scope. Scope is nothing but if you initialize a variable int a inside the main, this variable a, who can access it? How long can be accessed? Can it be accessed only by the main? Or if I write a function, just say void add, suddenly I write void add. And if in case I printf the value of a here, if I print the value of a, will the value of a automatically be accessed here? This thing is called as scope. How far is a visible for other functions? That particular thing is called as scope. And the second one is lifetime. Lifespan is how long will this variable a remain in our RAM? That is when we write int a, right? Whenever we write int a, 4 bytes of memory is allocated for the variable a inside the RAM, random access memory or your main memory. How long will that a remain there? Like even after the execution of the program, when we terminate the program, will a still be here or will a be removed? How long should it exist? All these things will be specified using lifetime of the variable, and scope will be shown that who and all and how long can this be accessed. So these are the two main concepts. Based on these two main concepts, storage classes were developed. Okay, in simple, storage class defines the scope and the lifetime of a variable or a function. That's it. This is the storage class definition. I'll repeat again. Storage class, sorry, storage class defines the scope and lifetime of the variable or the function. That's it. Okay. So now let's continue. Just give me a second. There are four types of storage classes. Please make a note of it. The first one is auto. The second one is a register. The third one is static. And the fourth one is extern. The first one is auto, the second one is register, the third one is static, and the fourth one is auto, register, static, and extern. I can demonstrate auto, I will demonstrate register, and I'll also demonstrate static. But I'm sorry, I can't demonstrate extern in this video because it needs Linux operating systems and I'm using Windows. So this won't work in my PC for now. But I'll show you the practical demonstration of all three as well. Okay. So first let's start with auto. Please make use of auto. Take the heading as auto. Whenever you will just initialize a variable, say int a or int b or float b, whatever it is, whenever you just initialize a variable without writing the storage class. Okay, first one, always remember, you have to write the storage class before here. You have to write the storage class here, like static space int space a, or you want it in auto. Okay, auto space int space a. This is how you specify the storage class of a variable or a function. Like if you are writing the function which I wrote here, void add, if I write static space void a, this is how you initialize. You can't write static extern. If you write extern space void space add, so extern storage class will be preferred for void add. Okay, this is how you have to specify what storage class you are using for. And the first storage class is auto. So now let's start. Auto is a by default storage class. Auto is a by default storage class, that is whenever inside main or inside a function you just write initialize the variable int a, compiler automatically suffixes auto behind it. Okay, auto is by default storage class of C programming. Remember this. Whenever you just write int a, auto storage class is preferred. And the data, the memory allocation for auto variables happens inside main memory, or you can also call it as RAM. Remember this. The auto, whatever you write auto, right? This happens inside main memory or RAM, and this has to be local declaration. It is local declaration. Auto variables are locally declared. That is after the end of the main function, after the end of main function or any function that you used. Let's say you wrote void add and you initialized int a here. Okay, after the execution of that function, when the compiler comes out of the function, the memory will be destroyed for it. So here, once we come out of here, the a variable of add that was created in memory will be destroyed. So the scope is local. The scope of the variable is local, that is limited inside the function, as well as the lifetime of the variable is also limited until the execution of function. Until the function is being executed, the variable has a lifespan. Once we come out of the function, the life is dead. Okay, in simple both are like this. Just take it like this. This is a auto variable, auto int a. Okay, it is a local declaration. The scope is also local, that is limited inside the function, whereas the lifespan, it will die here. A dies here. Once we come out of the function, a dies here. So this is the scope as well as the lifespan of auto variable. I'll show the practical demonstration of it. I have nothing to show for this, but still I'll show you that. Okay, and one more important thing, see here, if we have the program like this, int main, okay, and there is a for loop for I is equal to 0, I less than 10, I plus plus, I plus plus, okay, and I am initializing int a, okay, and I am setting the value of a is equal to 10, a plus plus, done, and I am closing this. What happens is, every time when we enter the for loop in the main memory, a variable a is created of 4 bytes. Okay, then the value 10 is set and a value becomes 11. Then a value becomes 11, right? Next time when we repeat the loop again, this line will be executed. The a value will be overwritten, that is again a new memory space will be created for a. Again the value will become, next time it will come again, this will be overwritten, new value will be created, again level will be stored. Are you initializing it? A value is been deleted and created again, deleted and created again, deleted and created again. That is because the main memory allocation is happening again and again and again and again and again. It's been reinitializing again and again and again and again and again. This is auto. Remember this point. You will get to know why I'm saying this. I'll show you practically. Okay. The second one is a register. A second one is a register. Remember, this is also local variable declaration. This is also local declaration. That is, the scope of the variable is inside the function. Void add. So here you have to specify register space int space a. This is how. Okay, this is a local declaration. Even if you write inside main, int main bracket open register space int space a. So the scope of the variable is inside the function, and the second thing, the lifespan of the function is also until the execution of the function. Auto and register both are similar in every single concept. Both are similar, same to same. The only difference is, in auto the memory allocation happens inside the RAM, right? Main memory. But for register, the storage will happen inside the register units, not in memory. The name itself says the storage happens inside the register. Register లో memory allocation అవుతుంది, not in RAM. That's it. This is for register. Same to same. Copy paste చేసుకోండి. Just make a small change that in register the memory allocation happens inside RAM. Inside a register unit. Okay. Remember this. And the other problem is the register size is limited. Okay, registers won't be 5 GB, 10 GB like RAM. So the size is very very limited. So when you're using register, make sure that you don't overflow the register, or else you will get some errors.
Extra static. Okay, the third type is static. So in case of static, the only difference is whenever a compiler comes to the line static int a, okay, int a, it will create a variable a in the main memory, and next time if by chance compiler comes to the same line, like if you have written this line inside a loop, this line won't be executed, this line will be removed. That is, if you write something like this, int main, okay, and if you have written like for loop for I is equal to 0, I less than and I plus plus, whatever the condition is, and you have written like static int a, okay, static int a is equal to 10, and you have written auto, let's say auto int b is equal to 10, a plus plus and b plus plus, and you are printing the value of a and b in printf and close, and close, what happens is first time when the compiler comes here, it will create a memory for a. Okay, it will create a memory for a in RAM, and the value will be set to 10. Done. And for b also the same happens. One point b value will be set and b value will be already stored to 10. Next a becomes 11. Okay, a becomes 11 and b also becomes 11. So first time 11 comma 11 will be printed out. Next time when it comes back again here for loop, this time it won't reinitialize the value of a, it will set it as 11 only. This line won't be seen by the compiler, this line will be skipped because it's static. But auto, it will come here again, it will reallocate, this will delete the previous memory, it will reallocate a new memory for a, again the value will be 10, again it will be printed 11. But here a becomes 12 because a plus plus happens, but this was not happening. So you will get an output like 11 comma 11, 12 comma 11, 13 comma 11, 14 comma 11 and so on. This is static, that is memory allocation in the RAM happens only once and is never rewritten back even if you re-encounter the same line. Okay, this is about static. Now let's talk about extern.
Go with the last type, extern. 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 Extern storage class is used to give a reference of global variable that is visible to all the program files. I am repeating again. Extern storage class is used to give a reference of a global variable that is visible to all the program files. In very simple, you will have two different programs. Say this is my program 1.c and this is my program 2.c. Is it clear? In program 1, you have hash include stdio.h. You have variable called as int count. You have initialized the variable called as int count, and inside the main, you are setting count is equal to 5. Is it okay? Count is equal to 5. And let's say we have a function, we have an extern function, write underscore extern, write underscore extern, close. Can you see here? I have not written the extern function in program 1.c, but in program 2.c, I am writing another header file hash include stdio.h. Here I am using the keyword extern int count, extern int count, and I am writing it void write extern. This function I'm writing here, meaning is written in this function. Printf, print the value of count is equal to percentage d space count. I'm printing the value of count here. Done. And this function, because since I don't have the meaning in the program 1.c, but I have the program in 2.c, you have to write here extern, that is to specify that the meaning is somewhere outside this function. Write extern space, write the full function name, extern void. See here, this is void extern void extern space void space write extern bracket open bracket close. This is prototyping. You're prototyping it as extern. This specifies that the meaning of void is written in some other header file or some in other file. So we have to find where it is. This is extern. That is, the scope is throughout the files, not in any variable. So the visibility is outside the program that you written. Multiple files can access that variable. And how to run this? To run this, you have to give the name of first programming file, gcc space program1.c space program2.c, program1.c space program2.c, then dot slash a dot out. I'm repeating again. I have stammered due to cold. I'll repeat again. The external storage class is used to give a reference of global variable, that is visible to all the programs, that is visible to all the program files. That's it. When you use extern, the variable cannot be initialized. When you use extern, right, you can't initialize the variable directly. However, it points to a variable name at a storage location that has been previously defined. So this particular thing is not initializing int count. Instead, it was already pre-initialized. It is just pointing here now. Is it clear? When you have multiple files and you define a global variable or function which will also be used in other files, then extern will be used in other file to provide the reference of defined variable or function. Same, I am repeating again. When you have multiple files, function program 1 and program 2. You define a global function. See here. This is a global function, right? This is not in any scope. Global function. Extern will be used in other file. Here we are using it. Extern will be used in other file to provide the reference of defined function. Is it clear? This function is defined in program 2.c. I am writing the keyword extern to tell that this particular file, this particular function is written somewhere else. So please go there and fetch. To tell in which file that extern is written, you have to compile the program in GCC space file name 1.c space file name 2.c, then you can give dot slash a dot out. Okay, the scope of the variable is outside the program, as well as the visibility of the program, and as well as the lifetime of the program is also outside the file. Okay, don't think that when we execute the file, the variable scope is over. No, the scope is throughout two different files, and lifetime it is still the execution of the function. Is it clear? So these are the four storage classes. I'm 100% sure extern is a bit complicated for you people. I don't know how other faculties are explaining. I'll explain it again if you want. If you don't want to listen again, just forward it. I'll explain only the program. See here, I have hash include stdio.h. Okay, this is int count. That's it. Once you initialize the count variable, if you want to use it in another file, you have to write like this: extern int count. Here, the count variable is not again initialized in the RAM. Instead, already it was initialized by this program. It will just point here. Both are accessing the same address, just like a pointer. Just like a pointer, both are accessing same variable. Just to think that instead of star p, we are writing this full line. That's it. And here, this is int a, okay? And you are still giving it like this. That's it. This is the concept, okay? So this is extern, where other file will point to pre-existing file, and to point between the files, instead of pointing in the same program, to point between the files, extern keyword is used. Okay, I hope this much is clear. If not clear, please try to understand extern. Auto register as well as static is very simple once you see the demonstration now, but extern you will have to put an extra mile. Okay, so now I'll show you the practical demonstration. Let's start. So I'll start showing the practical demonstration of static, auto, as well as register. But as I told, I can't show extern because mine is not Linux operating system. So let's start. First one is auto. See here, I'll just write in main, no other functions required. std stdio.h. Okay, int main, and I'm initializing a variable int a. Int a, the value is 10. So printf percentage d value of a. I am printing just the value of a. Value of a is equal to percentage d comma a, done, slash n. Is it clear? This thing is an auto where the memory allocation happens inside RAM. There is nothing to show. If I run this, you can see I'm getting a is equal to 10. First thing. Now I am creating another function called as void print add. I'm just printing. I'm calling void add. I'm trying to printf. I'm not passing anything. Value of a. I want to try if the value of a is visible here. Comma a. I'm not passing any variable. I'm not calling the function. I'm just calling the function add, but I'm not passing the parameter a. So let's run this. You can see here a was not declared in this scope. That is because since it is a auto, that is, even if you write like this, auto space int space a, both are same. Auto is by default compiler. If you run this, you can see here a was not declared in the scope because a is a local declaration. That is, the scope is limited inside the function where you initialize the variable. And second thing, scope. Once you come out of this program, once you close this program, a variable will be removed. It is only till the execution. When it's in the execution phase, that is, one second, when will it be executed? Once it is in running phase, that is, this is called as running phase. From here till here, program ended, right? 0.8206 seconds. This is the place, this is the lifetime of that variable. Once we came out of the program, once execution was complete, the variable died. That is the lifetime, and scope is in between the and scope is in between the function. This is auto. This is auto, right? Now I'll show you register. Same to same, no change. I told everything is same. Only difference is the data allocation happens inside a register, not in RAM. Everything is same. Run again. See here, starting from here to here, starting from here to here, the lifetime was limited. That is, when the program is under execution, the variable A has life. Once the program execution is done, the variable dies and the memory is cleaned from register. Second thing, it is also a local declaration. That is, any other function other than the variable cannot access it. See here. Here also it's showing A was not declared in the scope because it is limited till here. Okay. Next, static. A very, very complicated one. You write static here and you also write static here. STATIC. Okay. And I am writing static here just to show you. Static int A, but I'm setting the value of A is equal to 20 here. Now let's see what value will be printed. Can you see this? Can you see this? When I call the value A, I'm getting the value 20, which is correct. Okay, which is correct, absolutely correct. And inside the main, I'm getting the value of A is equal to 10. This is also correct because both are in local declarations. What happens if I declare it globally? Don't get confused. I'm removing this. I know this won't help you. Let's write only inside main. Okay, let's write only inside main. A plus plus, a plus plus. I'm removing static for now. I'm removing static for now. Just say this: for I is equal to 0, I less than 10. This is a bit complicated. You didn't understand, I'm sure, so I'm simplifying the example. See here, there's nothing. Okay, done. So this is just a normal integer that is of the type auto storage class. What happens in auto storage class? If I run this program, let's see this. If I run this program, see here, what's happening is every time we enter into the for loop, the value of A is reset to 10, A plus plus, and I'm printing the value 11. And this is happening 10 times. See here, 10 times 11 is printed because every time for loop is entering, int A is being executed, auto A is being executed. The same will go for register. If you write register int A and run this program, see here, same thing is happening, getting every time A is getting reinitialized inside a register. But if I write it as a static, it's a one-time initialization. Next time compiler won't run this line. So see now, in static, can you see? The value is not 11, 11, 11, 11, 11. It's 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That is because this line was executed only once. Next time when the compiler came here inside the for loop, this line was not even executed. This was already removed from the program automatically by the compiler. It's a one-time initialization. It is a one-time initialization. This static keyword line will be executed only once, whereas if you remove this line, this will be executed every time. See, 11, 11, 11, 11, 11. But if you write it as static, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. This is how. And the scope of static variable is inside the function. It is also local. Okay. The scope is local, but the scope is local. Okay, that's it. This is enough. I don't want to confuse you people. The scope is static, is local, and the lifetime is till the end of the program, till the end of the function. If you write it like this, I'll repeat it. Wait. If I write it like this, and if I remove this line, the scope is till the end of the program because this is a global declaration. But if I write it inside any function, the scope is a local declaration. Okay, the scope will be till the end of the program. That's it. So I hope you people are clear. Don't remember any theory concept. Remember the practical demonstrations. You can write it. And static variable memory allocation will happen inside RAM itself. Okay. Yeah. Done. Jai.